So, lesson 7. Lesson 7 is going to be looking over rationals, otherwise fractions, functions, and variation, like direct or inverse variation. Now, I don't have notes for you guys printed off, so just follow along as you see it, and then we'll take a quiz at the end. Okay? Alright, so a lot of this is kind of spiraled in. There's a little bit of review here and there, just to make sure that you haven't lost the touch as far as the earlier lessons are concerned. So what we're going to do is we're going to simplify each rational expression and state any excluded values. So looking at this, what's the answer if I simplified that? Not as easy to easily recognize, right? I mean, I would probably, and just to be 100% sure, distribute that 3 so that I had 2 cubed x cubed and then 2x cubed, which would make this 8x cubed and then 2x cubed, and that's much easier to see what cancels and reduces to forms of 1. Okay, so these, would you agree, reduce, okay, to a form of 1? And what does this reduce to? 1/4. So all of that is 1/4. Okay. Hopefully people don't see this and say, ooh, x cubed, that cancels. 2 and 2, that cancels. So the answer is 1. That's a common error. Okay. So let's look at the next one. What could I do to start simplifying? Otherwise, cancel, reduce. Take out a 3n. So take out a 3n from the denominator, so that what's left inside is what? 2n plus 5. Perfect. So now, can the 6 and 3 reduce? Yep, to 2 over 1, right? Can the n's reduce? So this would reduce to n squared, and this would reduce just to 1. Can this now reduce with this? No, it cannot, because it's not of a multiplication piece. This is of a binomial addition piece. So the only way that this n could reduce or cancel of some kind is if the entire thing, and I'm saying the entire thing, was up here in parentheses. Then the whole thing can reduce.
If you left it in the beginning and you didn't distribute the 3n, could you have canceled out?
Could you have canceled these out like this?
Yeah.
No, and that is a common error. Thanks for bringing that to my attention. You can't cancel that. And that's the understanding right there. This, you can cancel from both. Why? Because they share one term in the bottom, which deconstructed with a common denominator looks like this. That's why you can reduce both sets. This is not equal to that. You can't separate out this denominator like that. That's not how it works. Common denominator, the recognition of it is when there's one monomial term in the denominator. Okay? And of course, more than one in the numerator. Okay? Alright. So, what's left in the numerator? 2n squared. And the denominator? 2n plus 5. Can the 2's cancel? Again, no, they can't, because this 2 in the denominator is linked to an addition, not multiplication. You can only chip away and cancel between multiplication pieces. If this was in parentheses through multiplication, then you could do that, but because it's not, and it's with addition, you can't cancel out like that. Okay? Alright, so the third one. What do I do in the third one?
Try to factor the bottom.
Yep, let's factor the bottom. What is what are the factors of the bottom?
X minus 3x plus 2.
X minus 3x plus 2. And look at this, nice and convenient for us. We learned it in Algebra 2. Sure, in pre-cal or by pre-cal, that's called a removable discontinuity. It's a hole in the graph. Now, can these cancel? Yes, because multiplication exists between this entire piece. Do you understand? Okay, so what's left over as our answer?
1 over x plus 0.
No. And it says state any excluded values. X cannot equal what? Negative 2. Because the denominator can't be 0. Were there any, I kind of skipped over this one. This one was 1/4. This was 2n squared over 2n plus 5. What are the excluded values here? N cannot equal what?
5 or -5 halves.
Negative 5 halves? Or 0. N cannot be 0 or negative 5 halves. I know that you see the negative 5 halves right now, but can you tell me why this 0 is there?
Oh, when you plug it into the original, because it has 2 n's in the denominator.
True, yeah, when you plug it into the original you can check it, but this one, you could see it, right? Just from what was left over. Remember when we GCF'd the first part? We GCF'd out a 3n. You with me? And you had something that looked like 2n plus 5. In its factored form, guys, before you cancel reduce, this is where the 0 came. This is where the negative 5 halves comes from. Okay? Just like these factored forms, you see a negative 2 and also a what? Whoops. And also a positive 3. So we should account for the excluded values first before we cancel. Okay? Let's do that. Alright, so the top. This is why I showed you before the way I showed you. They will both multiply to get 2x squared. What are they? 2x and x. They will both multiply to get 7. What are they? 7 and 1. Now look, 7 and 1, the way I've shown you, will produce an 8 or a 6. But we need a 5. The last bit of this, for the quote-unquote difficult ones, is that you're not going to immediately go to that because of the fact that you have that 2 there. So you're going to contend with 1 and 7, and your goal is you have to decide where the 1 goes and where the 7 goes. All the while, this must produce the negative 5. If I put the 7 here, that's going to be a big number, isn't it? That's going to be a 14 and a 1, which would produce 15 or 13. We don't need that. We need a 5. So I shouldn't put the 7 here. I should put it over here, possibly. Do you agree? Okay. So let's put the 1 here, and now we just have to worry about what? Signs. So we have 7, we have 2. We have to make it become a negative 5 when we add them. Minus 7 plus 1. Right? So the top becomes 2x minus 7. That's the culmination of the way I showed you and why I showed you that way. What's the excluded value? Negative 1. X cannot equal negative 1. And what's the simplified version? 2x minus 7. Because that cancels to a form of 1. Alright. By now you're used to seeing the symbol f of x. Again, of x. There's no multiplication there. In place of y in linear and quadratic equations. Remember that the function notation is another way to indicate the x and y values, such as this. Means that in the function f, at 2, or when the value is 2, then the value of y, otherwise the answer, the output, is 7. We are used to writing that this as a point, 2, 7, like a coordinate point. And it will often help to to do so. So function notation can also indicate functions, shifts, reflections, shrinks, stretches, compressions, all that from parent functions, as long as we know the parents. Okay. So what is the parent function of this? What is the parent function of all of these? F of x. This is where we start. So we don't have an equation per se, but we have the function notation. And what change just occurred?
It was a
Shift.
Horizontal. So the first word is horizontal or vertical. Horizontal is with the x. Vertical will be the change in y. Okay? So horizontal translation or shift, either one. K units to the right. Perfect. Let's do the next one. This first word. Vertical. Because it's not inside with the x. So guys, when I mean the x, I mean like this x is inside the parentheses. Okay? And inside parentheses, here we go real quick. Whenever I say parentheses, I don't mean physical parentheses. On this one, it could be physical parentheses, but this means inside with the x. This means inside with the x. This inside means horizontal change inside with the x. Does that make sense? Anything outside of that, like over here or over here, is y. Over here or over here is y. Y'all with me? And then like outside or afterwards added, anything on the numerator or out here or added would be y change. And I do have a small little acronym. If it's with the x, you need to interpret the opposite. Okay, you can think ex-girlfriend, ex-boyfriend, whatever you want. That's why you're no longer with that person. They're your ex because you were doing the opposite. But if you do the y, like happy wife, happy life, I don't know, you follow the rule. Whatever helps you memorize this. So whatever is with the y, you're going to do what it says. Okay? So this would be a vertical what? Shift, because you're adding k units up because you follow the rule. What's this? Vertical, because it's outside, right? It's outside from the x. So real quick, just so that people know who are watching this, who are not in this class. All those are horizontal. And all of these are vertical changes because they're happening on the outside. Okay? So vertical what? Reflection. It vertically reflects. And if you vertically are reflecting back and forth, you're reflecting across what? Reflects across x-axis. The next one? Vertical stretch. Because you follow the rule. K is bigger than 1, it's going to stretch. It's like doubling your height, if you will. So vertical stretch by a factor of what?
Okay.
Of K. What's this?
That's a
Horizontal translation or shift. K to the left. Vertical shift. K down. Here's where that ex-wife or that ex-girlfriend, whatever ex-boyfriend comes into play. You're going to do the opposite. This is a what? Horizontal reflection, right? So reflection across y-axis. And then over here, it's a vertical compression. So it's going to shrink it. Vertical because it's not inside with the x. And it's going to be a compression by a factor of me give you some examples here in just a bit to test that. Actually, I'll give it to you now. From the shortcuts that I just gave you, let's go to one of the most difficult ones per se, okay? Let's do something that looks like that. What's the first, and the way I want you to list out these transformations are in PEMDAS order. So wherever X starts, in PEMDAS order, you would do it, okay? But the caveat is, you have to get the coefficient before you begin to what number? 1. A positive 1. So if I change this, oops, it would be what? 2 times x minus 2. Just like Emily said, we got it to 1. Now we can interpret all the transformations. Let's do the first one. Okay? So what is that? So horizontal shift 2 to the right. What's this? Nice. It's a horizontal compression. It looks like a stretch, but because it's with the x, right, just like I showed you over here, it's with the x, you're going to do the opposite. So it would be a compression by what? 1/2. And then what's this? Vertical reflection over the x. What's this? Vertical compression by 1/2. Because you don't do the opposite here. It's with the y value. You follow the rules. And then up 5. Vertical shift 5 units up. Okay. We will talk about transformations again. Okay. So here we go. So f of 0, that means you just plug in 0. What do you get? -5. So maybe you can see that really fast. If this is bigger with numbers, there is something that I showed you this week, synthetic substitution. If you show the coefficients in descending order, x squared, x, and constant, you could plug in this 0 here, copy, multiply, oops, add, multiply, add. And this answer would be the same. Okay? Higher math, that becomes a good skill to have for speed and accuracy. Let's do this -3. A lot of people miss the negatives because they forget to put them inside of what? Parentheses. So if they forget, what's -3 squared? Times 2. What does this become? -9. So what's my answer? 4. Just 4, right? If you struggle with negatives, look at this synthetic substitution. 2, 3, -5. Look at this. Copy, multiply, add. Multiply, add. I think it's easier that way. When you're first exposed, you're like, why? Well, there's a good reason right there. You know what I mean? So all values of x such that f of x is equal to 0. What is that asking for? To factor it. We're going to set this equal to 0 and solve. They will first multiply to get 2x. What should they be? Or 2x squared. What should they be? 2x and x. Factors of 5? 5 and 1. Where should the 5 go? Here? Okay, with the 5, with the 2x. And then last but not least, +5, -2. Do you see it? So now x will equal -5/2 and 1. Guys, do I have to check these answers? No. Because it's quadratic and why? The domain is all real numbers, so there will be no extraneous solution. Nice. Alright, so given the following, we're going to write a linear function in slope-intercept form. I start this?
You can find the slope.
So you need the slope from 2 points, right?
You
Y2
do
minus
y2 minus y1.
over x.
Yep. And where do I get those from what was given?
30 plus 6 over 1 plus.
So some people don't see it as easy as you do. So what I'm going to do is I'm going to make these into ordered pairs. Do y'all see it? So then it will be 3 minus negative 6 over 1 minus negative 2. And the slope is 3. Now we want it in slope-intercept form.
Put it in point slope form.
Put it in point slope form. So if we do it in point slope form, we can pick any one of these. It doesn't matter. Let's go with 1 and 3. Y minus 3
Plus 3.
equals the slope times x minus what? 1. And then you can do 3x minus 3 and then add. And what's your final answer?
3x.
3x. Okay? Alright, so we have the following is given, and we are trying to find these composite. Oh, sorry. So we're given x squared, and what is the effect that this has on the transformation on the y-intercept?
Your y-intercept would be -2.
-2, yep, because this is here. And this was a vertical shift 2 down. So that the graph would look like this. So the y-intercept is y is -2, otherwise 0, -2. Okay? Alright. Function composition. We have two machines here. We have the F machine and we have the G machine. In our problem in A, what gets done first? How do we read this? How do you read that?
You have to solve g of it.
F of G of X, yep. This is read as F of G of X. Otherwise, you could also write it like this. Looks like fog, but it's F of G of X. The one closest to the X is the one that you do first. Okay? So, okay. So G of X is going to be done first, and whatever we get from G of X, we're going to plug it in as the input into F. So this is what we got for G of X. We're going to plug that as the input for F. So I would say F of X, I would say equals, do y'all see how this is very similar to the outer shell of F? And now all we have to do is just insert what we got from G of X. So that my final answer of this two-step process is x squared minus 2x plus 6. Okay? The next one we're going to do is G of F of X. This time we're going to do the F first. So what did we get for F? Well, we got this guy. And we're going to plug this in to G where all the inputs belong. Because this is what this is asking. It says take F's answers and plug them into G inputs. So we have parentheses squared minus 2 parentheses plus 1. And all you're going to do is plug in your output from the first step. Go with me? Alright, so this becomes x squared plus 10x plus 25. This is minus 2x minus 10. And if I combine all this together, what do I get?
X squared plus 8x plus 16.
Plus 16. So G of F of X equals all that. And now, this is the same. The only difference now is that we're going to plug in a number. We're not talking about X. Okay, a variegated variable of just X. So if I plugged in this -1 into G, here we go, 1, -2, 1, I'm plugging in a -1 So copy, multiply, add, I should get a 4. Okay? So the answer to this is 4. What am I going to do with this 4? I'm now going to plug it into F. And what's my final answer? 9. So I'm going to put F of G of negative 1 is 9. Any questions? Alright, so use structures to isolate or identify a quantity of interest. So, looking at this first one, it says, often on standardized tests you will be asked to solve for a formula for one of the quantities in terms of quantities. This is huge. So, can someone read this for me using these words? Can someone read this equation using those words? Let me help you. C is written in terms of R. You with me? What would this be? A is written in terms of R. Just R. Y is written in terms of X. You starting to see it now? So all the operations mean nothing. All of the constants mean nothing. That's why this is not saying pi. It's saying C is written in terms of R. This variable is written in terms of this other variable. You with me? In terms of is big, okay? Remember that you follow the same process whenever you would if solving an equation that had constants rather than variables. So for instance, use the area formula for a triangle, which is 1/2 times base times height, and solve for the height. Look at this. Solve for the height in terms of, that means get h alone, and all this in terms of is the area and the base. You with me? So that means when you see something like this, that means whatever's in front of this in terms of, get it alone. Okay? So we're going to get h alone. Let's move this 1/2. How do you move this 1/2 to the left? Multiply by 2. Let's move that b. How do we move the b to the left? Divide by b. So now check this out. H is written in terms of a and b. You with me, guys? So if I did like the dirt formula, this is D is written in terms of what? R and T. Nicely done. Or you could say R is written in terms of D and T. So who cares what the operation is? You're just identifying the variables. And you could also say T is written in terms of D and R, or R and D. You with me? Okay. So the equation of the surface area of a cone is this. Okay. What is the slant height? Basically, get L in terms of the area and radius. So get L alone. What should I do?
Well, first distribute the pi.
It's all good. So you could subtract the pi r squared. And then what? Divide by negative pi r. Now you have L written in terms of and r, not pi. Cool? Someone might have seen this and said, well, you could also GCF out a pi r. Do you agree with what I just did? All I did was GCF out a pi r. And then if I divide this, what would I do at the end? I could subtract the r and then divide by a negative. Or, you know me, I like the positive coefficients of the variables I'm going to get alone. I would add L to the left side, and I could subtract A onto the right side. Are these two the same? They are equivalent to the same. You just have to multiply by forms of possibly -1 over -1.
Would you cancel the pies over?
Oops, I'm sorry. Go ahead.
Can you cancel the pies on that side?
You cannot, because this is not multiplication. You can only cancel between multiplication pieces. Okay? Good question. Thank you. Alright, so let's move on to the last two. Direct variation looks like this. Inverse variation looks like this. And the way you read this is y varies directly with x. This is y varies inversely with x.
What about indirectly?
There's no indirectly. Okay? So check this out. Watch the highlights. Y varies, because you're going to be given this, guys, right here. You are going to have to create this, and you are going to have to create this. So y varies, that means equals k. No one would know that. Directly means to multiply, and then with x, it's just your variable. You with me? So let's do it again. Y varies, that means equals k. Inversely, that means to divide, and then with x. And if you notice, these problems are cake. Like, they're so easy. Like, you read this, x varies inversely with y. I write what? What do I write? X varies, that's x equals k, divided by, because it says inversely, with y. So I have to read this to create this general equation. Now I can conditionalize my inputs. So if x is 6 and y is 3, our first step is to find k. Can y'all tell me what k equals? 18. So that we can make this general form into a more particular form. Otherwise a direct variation, particular, and it would look like this. X equals 18 over y. It's like using the point on a y equals mx plus b to solve for the intercept of b. Y'all remember that? Whenever you had something that looked like this, and if you had a point, you could use this point here and here, and then like this one here and here to help you find b. You go with me? So if you did, you would say 6 equals 4 plus b, so that b is -2. So you would write this general form into a more specific particular form of this. Your goal is to do that. You just did it so that you can find x when y is 7. What's the answer? 18 over 7. Do y'all see the correlation between that and y-intercept form? Just the process of trying to find that. Alright, so write an equation relating x and y if y varies directly as x. So y varies directly with x. So x is 2, y is 5. Whoops, that's not a 5. So what is k?
It's 5 over 2.
5 over 2. So we're going to use this to make this more particular, which we get y is equal to 5/2 x. So what is... Oh no, that's it. That's our equation. It's not looking for something else. Okay? And our last one. Here's how you most likely to see these types of problems in standardized tests. Write the formula for the following. Z varies directly as the square of x and the what? And inversely as the square of y. Notice that when we solve directly, we multiplied with the square of x. When we solve inversely, we divided. Not the square root, but with the square of 2. Just don't forget the k.